Hello everyone, welcome to RN tutorials on engineering mechanics. So in this video we are going to discuss about how to find the moment of inertia of hollow rectangle. Okay, so here we are already told you we are going to find out how to find. We are going to discuss how to find the moment of inertia of hollow rectangle. So for that I want to consider a hollow rectangle as shown this figure. Okay, this is the hollow rectangle which is having a hole inside of it. So to this rectangle, hollow rectangle, how to find out the moment of inertia? Let's discuss. So first I would like to give the names to the corners of the outer rectangle here. So before that, here I have represented the axis x-axis and the y-axis. So with respect to x and y axis, we have taken a hollow rectangle. So to this hollow rectangle, I want to give the names to the corners now A, B, C, D like this. So again I would like to represent what is the breadth of the rectangle here. The breadth as B I would like to assume, and similarly depth as D, that is BC for the rectangle ABCD, and similarly the inner hollow shape that is in a rectangle. So for this also inner corners I want to give the name as EFGH, and for that inner rectangle which is the cutout portion, okay, which is giving the hollow, that is the whole shape. So for that also I would like to mention the dimensions as B1 as breadth and D1 as depth for the cutout portion which is the hollow shape in a form of the rectangle. Okay, so for finding the moment of inertia we should know what is the moment of inertia for the rectangle. Already we have discussed in the previous video, that is the derived formula. So now I would like to write the moment of inertia for the rectangle. That means we already know about what is the moment of inertia of the rectangle, that is about x-axis. Ixx is equal to, we can write it as bdq by 12. Okay, already we have derived. And next I would like to write the moment of inertia of outer rectangle ABCD. Okay now, so for finding the moment of inertia for this entire shape, first we need to write the moment of inertia for the outer rectangle which is ABCD about the same axis XX. So that can be written as we have assumed that breadth as B and depth as a D as it is in the formula. Already we know that we can write as Ixx is equal to BDQ by 12. Okay, so now again we try to write the moment of inertia of cutout rectangle, that is the hollow shape already is there. So cutout portion is also in the shape of the rectangle. So for that also moment of inertia about the x-axis we can write it as per the dimensions we have assumed as b1 and d1. So this for this cutout portion we can write the moment of inertia as b1 d1 cube by 12. Okay na, so these are the two moments of inertia for outer rectangle and the inner rectangle. So for getting the moment of inertia for the entire rectangle, hollow rectangle about xx can be written as Ixx is equal to moment of inertia of total rectangle ABCD minus moment of inertia of rectangle EFGH, that is the inner rectangle we can consider. So if you consider ABCD as a whole body, when you subtract the moment of inertia of the inner part which is consisting of a hole, so automatically you will be getting the moment of inertia of the hollow rectangle. Okay, the total entire hollow rectangle. So these two formulas already we have written, so try to write the formulas here again. Moment of inertia of ABCD is BD cube by 12 minus moment of inertia of EFGH is B1 D1 cube by 12. Okay, this is the formula for finding the moment of inertia of the hollow rectangle if we know the dimensions of outer rectangle shape and the inner rectangle shape. Okay, and similarly about the y axis also we can write in the reverse form. So iy is equal to db cube by 12 minus d1 b1 cube by 12. Okay, in the reverse order, in place of breadth we have to take the depth, in the place of the depth we need to take the breadth when you want to find out the moment of inertia about the y axis. Okay, so these are the two formulas we can take for finding the moment of inertia for the hollow rectangle about x axis about y axis. Okay, this is the simplest method of deriving the equation for the moment of inertia for the hollow rectangle. So by using these two formulas directly in the problem, we can find out what is the moment of inertia value for hollow rectangle. So I hope you understand the simple equation derivation. So still if you have any doubts, please feel free to give a comment to my video. so that I'll try to clarify your doubts. And once again, thanks for watching my video. Thank you all.